IGCSE Computer Science, and this is the final output device that we need to know. This is projectors. So, in case you don't know what a projector is, it's a device that displays computer output onto a wall, large screen, or even in interactive whiteboard. So, we usually see these in meeting rooms and classrooms as well. So if you remember what we looked at when we looked at interactive whiteboards and how they're quite big, so a lot of people can actually see what's displayed. Well, this is how the computer is. The computer screen is displayed. It uses a projector, and if the projector and interactive whiteboard work together, then they can do some cool things. Now, I know that this might seem quite old because, projectors came out a few years ago, but you still have to know about it. They kind of look like this, although they can look a bit different. Some go on walls as well, so yeah. So projectors are usually used in presentations and multimedia applications. And there are two common types of projectors that we're going to look at. There's the digital light projector and the LCD projector. So, yeah, let's jump into this. So, DLPs use millions of micromirrors on a chip. The number of micromirrors and the way they are arranged determines the resolution of the image projected. So when the micromirrors are tilted towards the light source, they are on. When they are tilted away from the light source, they are off. The micromirrors can be switched on or off thousands of times a second to create various shades of gray. Anyone? No. The typical number of gray shades... Actually, I haven't seen 50 Shades of Grey. The typical number of gray shades which can be produced is 1024. So, let's look at an example. If, we're not really looking at the example, I'm telling you the example. You're kind of looking at the text, but if the mirror turns on more times than it turns off, a lighter shade of gray will be produced. A bright white light source from a xenon light, for example, passes through a color filter on its way to the DLP chip. The light is then split into three primary colors, red, green, and blue. And the on and off states of the mirrors are linked with the three colors to produce the colored image. Over 16 million different colors can be produced. So, that was DLP projectors. Let's look at LCD projectors, which isn't that much. In fact, this video is, as you notice, is pretty short. So, LCD projectors, let's look at how they work. So, step 1, a beam of white light is generated from a bulb or LED in the projector. The beam is sent to a group of chromatic-coated mirrors, which reflect the light back at different wavelengths corresponding to red, green, and blue light components. These colored light components pass through three LED screens, or LCD screens rather, not LED screens, and a red, green, and blue version of the gray image emerges. And finally, these are combined using a type of prism to produce an image consisting of millions of colors. This image is then passed through the projector lens onto a wall, screen, or interactive whiteboard. And that's pretty much it. Well, LCDs are a little bit older than DLPs, and they don't have the mirrors which turn on and off. They have these mirrors which reflect the light back at different wavelengths. So, yeah, it's pretty much that's how it works. I don't know what else to say. Actually, I do know what to say now. This is finally we're finished with devices. We're finished with input and output devices. Well, I wouldn't say we're finished with devices because we have memory and storage, and we have to look at a few more devices, but it's not that much. So, off the top of my head, it's just RAM, ROM. Then magnetic storage, optical storage, solid-state storage, and file sizes again. But yeah, it's pretty much it. Thanks for watching, people, and yeah.